Solved MCQs about the state of matter, that is gases. For a given mass of a gas, if temperature in Kelvin is double and the pressure is also double, then the volume of the gas will be, there are many options given, so we will solve it. From ideal gas equation from gas laws, PV is equal to nRT. Here N and R are constant, so we will remove it by rearranging this formula. V is equal to T by P. Now the question is about doubling of temperature and pressure. So we will put here V dash, another volume, 2T doubling of temperature divided by 2P doubling of pressure. So 2 and 2 will cancel out. We will get V dash is equal to T by P. Now by doubling the pressure and temperature, we will get the V dash, that is also equal to V. So the answer is unchanged. If 32 gram of oxygen and 22 gram of carbon dioxide are taken in a container at T degrees C, then the partial pressure of oxygen is. So we will also solve it. First we will find the mole fraction, because the partial pressure has a formula, mole fraction multiplied by total pressure. So we will find the mole fraction. For that we will calculate the moles. Moles is equal to mass divided by molar mass. Moles of oxygen, mass of oxygen is given in question, that is 32 gram, divided by 32 is molar mass of oxygen, so we will get 1 mole. For moles of carbon dioxide, 22 gram is given in question, 44 gram is molar mass of carbon dioxide, we will get 0.5 mole. Now by summing these two, we will get the total number of moles, that is 1.5. Now a mole fraction has a formula, mole fraction, mole of that component divided by total moles present in the mixture. So we want to calculate the partial pressure of oxygen, so here we will calculate partial pressure of oxygen multiplied by total pressure, sorry, mole fraction of oxygen multiplied by total pressure. So 1 by 1.5 multiplied by P is the answer. So option A is the correct answer. For a given mass of a gas, if at T degrees C, if pressure is increased by 3 times, then the volume of the gas will be, there are many options given, so it will also require some solving procedure. V is equal to K by P according to Boyle's law, or we can say that pressure and volume has inverse relation according to the Boyle's law. So we want to find V dash, because we are going to change V to V dash by changing the pressure 3 times, by increasing the pressure 3 times, that is given in question. So K divided by 3P. So we will get 1 divided by 3 or K by P. K by P is equal to V according to this equation. So the volume, the new volume will be 1 by 3 of the old volume. That is, answer is C. A gas if used is 1 by 4 as fast as helium. The relative molecular mass of the gas is, so it will also require some procedure. Rate according to the diffusion law, law of diffusion, rate of diffusion of any gas is inversely proportional to the square root of their masses or densities. So here we will find the molecular mass. So rate of diffusion of X is equal to inversely proportional to the square root of molecular mass of X, and for helium it is inversely proportional to the mass of helium. So the rate of diffusion of X is given, that is 1 by 4. So we will put for helium as 1. So again squaring these equation, whole equation, the square root will cancel out, and squaring this side, so we will get 1 by 16, and here remove the square root by squaring. So again cross multiplying it, so mx, that is mass of unknown gas, is equal to 16 multiplied by mass of helium, that is 4. It is equal to 64 gram. So 64 gram is the answer. A pressure of a gas in a container is due to collision of molecule with one another, due to collision of molecule with wall of the container, due to collision of molecule with top of the container. We know that pressure of a gas in a container is related to all of these above options. So all of the above will be the correct answer. Carbon monoxide and nitrogen has the same rate of diffusion at STP. This is due to the fact both are diamagnetic, both are gases, both have same relative molecular mass, and both have same bonding. We know that from the rate of diffusion, or from law of diffusion, the rate of diffusion of two gases is related with its molecular mass. So we will solve it. Molar mass of carbon dioxide is 28 and molar mass of nitrogen is also 28. It means that these both have same molecular weight, so they have same rate of diffusion. So the option C is the correct answer.